That one is still unclear. I guess if people are concerned about the spike of the maximum memory usage, that we can open another issue. Then the CPU intensive endpoint, as I added in the comment, I'm still unclear how to proceed that. Basically is in my local experiment, there are several small simple observations. The result is not very consistent when I read today, yesterday, one time, another time. It's not very consistent. And another observation is the most time consuming part is the queue duration. So that's GitLab workhorse queue time. But I feel like we don't really care this part in the local DDK environment. Then the view time sometimes is higher, sometimes is slow. I guess the view time maybe we don't really care because there's maybe the grep API is common to every API. That's just my guess. And then the last part, sometimes the DB time, it varies from 100 milliseconds to sometimes around 1 second, or it's bigger sometimes. Maybe that part is in some case we are concerned about, but I'm still not sure whether it's a duplication of another issue Craig mentioned, and I'm still not sure what's the efficient way to proceed and find where is the optimization opportunity. So I don't know how to continue. So I just hope I can get more advice from the discussion on Wednesday. There is a scheduled session, so hopefully Camille and Igor and everybody can give me some suggestion, or we can have some information there. So for that reason, I temporarily don't have much issues to work on before the Wednesday session. So I temporarily choose another issue from the backlog. Then I work on that new issues from tomorrow and until on Wednesday after meeting. I guess maybe I can have some information how to proceed with the CPU endpoint, intensive CPU endpoint.
Okay. Thanks for the report. And yeah, I guess the idea of Wednesday meeting is exactly the one you mentioned to understand the profiling better. Can we reproduce CPU intensive endpoint? Is it the same?
No, the API endpoint is not exactly the same.
But okay, but it also related to Wednesday, right? Okay.
The Wednesday part is majorly about the CPU intensive, but I'm not sure. Maybe there are some other related endpoint. Camille mentioned we have potential other endpoint we can do some improvement, but that depends on the discussion and the findings or debug sessions results, I guess.
Okay.
If you look at the issue 30180, I recently linked that related issue on there that another team is looking at. I think Chinyu, you've got the screen, right?
Yes.
No, it's me. It's my screen.
Oh,
no, that's.
What do you want me to open?
If you open up that issue,
yes.
Yeah.
30180.
No, that's the wrong one. Sorry, it's the other one.
This one, right? CPU intensive. Yeah. Sure.
Yeah, Chinyu links it there. So 33150.
33. This one, right?
Yeah. So there's seems like these two are related, and I'm not sure if anybody is caught up with the other team that's working on this.
No, I didn't check that one. Okay, we could check them and decide if they're connected. Is there anything anyone want to add to these two issues, like memory and CPU intensive ones? For now? No? Okay. Let's move on. Craig, could you please comment this section?
Yeah, it looked like because that memory intensive one closed, and because the CPU intensive issue may be a duplicate that another team's working on, just wanted to call out that the issues in the milestone board are ordered in priority order from top down. So if you're looking for work, just grab the next one in the 12.5 column that's not assigned. And it sounds like Chin Yu already did that anyway as he was looking for work. So
okay,
that was all.
Okay. Next is Camille for his two comments. Camille, do you want to share your screen, or do you want me to open these issues? Okay. So let me open the issues for now, just to check. Just open and be familiar with them. So the first is enable calculate composite status in Ruby instead of using SQL. They merged this one.
Yeah. Yep, we can hear you.
Okay.
Now.
Camille, do you want to share your screen, or is it okay?
No, I don't think.
Okay.
I'm working on these two items to move them forward. I'm now kind of looking over the performance metrics from the dev to understand if this is on the pair or is it regressing the performance. I posted some data at the bottom. So far, the data that we got from the staging, it's fully non-conclusive. I don't understand the data from the staging. So I'm kind of now cross-checking that with the dev, because my data shows that this is roughly, it behaves pretty much the same as it was behaving before. So it's kind of expected the outcome. That's it. And it's kind of I'm doing that in the context of this issue, that I plan to finish this milestone likely. And I want to finish this one. It's being open, there is some open discussions on that one, but I think that I have some idea how to move forward, or move some of this discussion to the separate MRs to have it match as a first iteration.
Okay, thank you. So from my side, I wanted to add that I returned to my work on the import, and the last merge request in queue for now from the series of refactoring proposed by Camille is ready to be reviewed, and I will send to a review. And while it's under review, I will take one of the tasks from the milestone board, as mentioned by Craig. Is there something you want to add? Anyone? To today's agenda? No? Okay. Then please have a great day. Have a great week. See you. And bye-bye.
What were you going to say, Camille?
I was saying to Chinya about this CPU intensive merge request. It seems that the description of this issue says you need to have a lot of data, a lot of merge requests to see the performance regression. So I think that there are two sides of this issue, one having a lot of data to render that, and the queuing time that you see on the workhorse is because of the Unicorn or Puma unable to process this. So in general, I think that we are looking for reducing amount of the queuing by making this endpoint to basically faster to respond. So if you have some ballpark number of like 500 milliseconds to execute that, we want to make this like half of the time, pretty much. So you're gonna see like improvements across the board on this endpoint.
So do you mean even the queue duration is something we can also consider to improve?
Queuing duration, it's the outcome of the performance of the endpoint. If you improve the performance of the endpoint, there's gonna be less queuing because this endpoint is gonna be faster to execute. And if you have the capacity that allows you to process 4 requests at the given time, and you process these 4 requests in the half of the time, you can effectively in the same unit of time process 8 requests. So you're gonna have much less queuing on the workhorse of these requests waiting to be processed.
Okay. So
like as the outcome of the optimization, you're gonna see like the shorter queuing time, because like you are being bottlenecked by the Unicorn or Puma being unable to process these requests quickly enough to not have any queuing in the first place.
But so in that case, the queue, because the local environment, the Puma server and the Unicorn server, we may not have the same capacity as staging server or production server. So the app server, Puma app server in production can be much powerful, have more CPU resource, have more memory resource. So
yes, but like it still doesn't make a difference because like what you want to achieve, you want this request to finish as quickly as possible, regardless of the capacity that you are given. So if it takes like 1 second, it's just too long. It should take like 100 milliseconds. This is like your goal in pretty much every case. That like the request that is being executed by the Unicorn or Puma, if you run this request, just 1 request at the given time, in ideal condition, it should like finish in like 50 or like 100 milliseconds, regardless of what you do and how big data set is.
Okay. Then maybe I can simply try a little bit with the more data set. Right? I just add more data in the data set. There another thing. I'm still wondering about the queue duration, but I can try a little bit more because I remember the first time I see the big queue duration, it was the first time I see this data, I wasn't using the performance test script. I'm just simply run a loop to do a local curl request. So the local curl request, it basically just run 1 API request every time, then followed by another one by one. It shouldn't be a big pressure for the application server in my mind. But I can try a little bit more.
So yes, this is actually a very good test because like what you want to do if you run in the sequence, the request, you're not gonna have like the saturation of the capacity that you have on the web server. What you want to achieve like in the sequential execution to process as many requests in the given unit of time, like 1 second. Because like otherwise you're gonna start seeing if you fire like 10 requests and you have the capacity to process at most 4 at the given time, you're gonna start hitting the saturation and the queuing on the workhorse. But technically what you want to do, what you want to optimize this single request to not take 500 milliseconds in ideal conditions, but take like 50 milliseconds at most. This is what you want to really optimize. Like you want to optimize like the smallest unit to be super fast, because then if you like kind of stress test, it's gonna have much higher capacity to process multiple requests in the given unit of time. But technically, like your smallest item is like your request. If it takes like 1 second, it's basically too long. It should take 50 milliseconds or like 100 milliseconds in some special circumstances, but never really any longer.
I see. Okay, cool. That makes sense. Okay. Yeah, okay. It looks like I don't have the I don't have the reference common sense of what usually a normal efficient request should be. So yeah, okay, I see.
So I think like that our baseline is really like that everything takes like something between like these 50 to 100 milliseconds at most. I don't know what is like the current duration of that endpoint. Maybe we could check that, but it seems that like for the big set of the data, it's just too long. It's very expensive to get this ungenerated data. And if you look at the discussion from Igor, he and like some other folks there, they are mentioning that there's like a few hundred SQL queries, a number of Git calls. It seems to like be very inefficient in the way how it is doing today.
Cool. Okay. Thank you. Thank you, Camille.
Okay. Thank you.
Thank you. See ya.